Okay, yeah, integumentary system, fun and fancy word for skin. Okay, our integumentary system, or the skin, is the largest organ in your body. Okay, it accounts for about 7% of your body weight. That's not an insignificant portion of your body weight, okay? It varies in thickness from about 1.5 to 4.4 millimeters. So, like this versus this, very small difference, but in skin, it's a lot because all of that is layers and layers of cells. Your skin is divided into two distinct layers. Does anyone know what those layers are? Yep, exactly. Your epidermis and your dermis. Your epidermis is on top. We know that. Epi means on top, right? So your epidermis is the top layer of your skin, and then the dermis is deep to that. There is a third unofficial layer of the skin called the hypodermis. The hypodermis, or the subcutaneous layer, also known as sub-Q. If you've ever had to get an injection, like in your thigh, maybe thigh's muscle, but like in your stomach, kind of right in here, there's some hypodermal tissue. There's a couple of hypodermal places that you'll get some injections every once in a while, okay? Like I said, it's not technically part of your integumentary system, but it shares some of your skin's properties, so we like to talk about it kind of all together, okay? So this is kind of just a general look at what your skin kind of looks like. There's a lot of stuff going on here. Don't let it overwhelm you too much, okay? So this bit here that I'm kind of outlining in black, that's the epidermis. And then you have the dermis below that. We'll talk about the papillary and reticular dermis when we get there, okay? That's what it looks like on a human being, a dissected human being at least. Epidermis is that first layer, dermis is second, hypodermis is third. You'll have some deep fascia and then the muscle. So it's all covered, okay? When we talk about the skin, there's a lot of different functions that the skin has, okay? But there are 5 main ones that we will talk about. The first is protection. Your skin, it functions to protect your organs and other underneath processes from chemicals, from abrasions, from water loss, from UV damage, all kinds of stuff, okay? All of those layers of stratified squamous epithelium help to protect the stuff that's underneath, all right? Next thing that your skin does, it helps with body temperature regulation. Throughout your skin, you have sweat glands and capillaries that kind of open up and help to release some of the heat from your body, okay? So it helps to kind of regulate your overall temperature. Another thing that your skin functions to do is it has some excretions. Excretions are just stuff leaving, X out, stuff leaving, okay? Some of those things can be urea, which is a protein, salts, and water. That's usually lost through sweat. We'll talk about sweat a little bit later. Fourth function of the skin is to produce vitamin D. Vitamin D is necessary for your body, and your epidermal cells use the UV rays from the sun to help synthesize this vitamin D. That's why people say, go outside and touch some grass. That's real. You need to go outside so that your body can synthesize that vitamin D. Vitamin D is a precursor to a whole bunch of different hormones and proteins that make you happy, sad, all kinds of jazz. Okay? So if you're feeling bad, go outside, stand in the sun, and rotate like a rotisserie chicken for like 10 minutes, and you'll feel a little bit better. I can almost guarantee it. Okay? Cool. Fifth thing that the skin does is sensory reception. Your skin has all kinds of different sense organs with nerve endings attached to it so that you can perceive the world around you and or near you, right? You can feel it if your hair is dragging on your body in a weird spot that you've never really felt it before, feels like there's kind of bugs on you. Think your skin, okay? So sensory receptors. Cool? Cool. Okay, so the epidermis is made up of keratinized, stratified, squamous epithelium. That keratinized is important. Okay? And we'll talk about why that keratin is so important in a second. Within that epidermis, you'll find 4 main cell types. Okay? The first is keratinocytes. What do we think keratinocytes might do? They make keratin. Because again, biologists are what? Not creative. Right. Okay? So, keratin cells. Keratin site. Keratin cells. Okay? You'll find them in the stratum spinosum. We'll talk about what the stratum spinosum is in a little bit. As well as sometimes the stratum basale. But we'll talk about that later. Okay? They produce keratin, which is a fibrous protein that also helps in waterproofing. Unlike alpha, you will not melt if you touch water because of keratin. Okay? You with me? Y'all got that Wicked reference? Yeah. Catch it. Okay, next cell is melanocytes. I think you all know what melanocytes do. Melanocytes help to secrete pigment that gives your skin color. There's different types of pigments that your body can create, but the one that we talk about for the most part are the melanocytes that make melanin. Okay. Next cell we're going to talk about are tactile epithelial cells. Those tactile epithelial cells are also called Merkel cells. You'll find those mainly in the basal layer, and they're usually attached to a sensory nerve ending, okay? Those tactile epithelial cells help your body register things like pressure, okay? So you'll find those cells kind of in the deeper layers of your skin. Last cell we'll talk about are the dendritic cells. Dendritic cells are essentially your immune system cells. They like to hang out sometimes in the skin, especially as a protective mechanism, all right? So they're part of your immune system. They're usually pretty macrophage-like. You can kind of think about them as the soldiers in the storm, That's not how you spell soldier. Good Lord. Soldiers in storm. Good to have around. Okay. Cool. All right. So these cells are the most abundant in the epidermis. Okay. They produce a tough fibrous protein. They show up in the deepest layer of the epidermis, and by the time they get to the top layer of the epidermis, they are dead. What cells do we think they might be? What was that? Blood? Good guess. Blood cells usually don't get to the top of our skin system. We talked about them though. Keratinocytes. Keratinocytes. Keratinocytes are the most abundant cell type in the epidermis. Okay? They produce keratin, which is a tough fibrous protein. They also produce some antibiotics and enzymes. And by the time they get from the bottom layers of your epidermis to the top, they're usually dead. So you can slough those off. I probably just sloughed off a whole bunch of keratinocytes. They're all dead. Great. Don't need them anymore. Okay? They will regenerate. Now let's talk about the layers of the epidermis. We talked about how the skin itself has two layers. It has the epidermis and the dermis, and then the official, unofficial hypodermis or subq. Okay, that epidermis has layers in and of itself. There are 4 to 5 layers, depending on where you are in the body. Okay. So if we're starting from the base or the bottom, this layer is closest to the dermis. Okay. We start with the stratum basale. What does that BAS root mean? Base. Yeah. So it is the base layer. It's also sometimes called the stratum geminativium. Lord. Let's get this out of the way. Geminativum. So V-U-M. Okay. Next, we have the stratum spinosum. Next is the stratum granulosum. Our special one is the stratum lucidum. Lucidum. And then the last is the stratum corneum. If I were to draw kind of that base, so if this is stratum, actually let's start bottom to top. Stratum basale is just our fun, festive base layer. Stratum spinosum has some spiny-like projections, at least when we look at them. Stratum granulosum has some granule-like cells in them. And we'll talk about all of these layers in deeper depth. This is just a quick little overview. Our special guy, stratum lucidium, and then our top layer, stratum corneum. basale, spinosum, granulosum, lucidium, corneum. Okay. You will only see stratum lucidum in thick skin, such as the skin on like the palms of your hands, the soles of your feet, right? Places that get a lot of abrasion. Okay. So this is kind of what we're talking about, what we're looking at here. Stratum basale, this is that deepest layer. Stratum spinosum. Stratum granulosum. And this one does not have a stratum lucidium because you only see that one in thick skin, okay? And then that's stratum corneum. Again, looking at it in a different kind of view, I guess. This is dermis. This layer is basale. This layer is spinosum. This layer is granulosum. And this layer is corneum. By the time the keratinocytes that started down here get all the way up here, they are dead. They actually usually die kind of right around here. Why do they die kind of right around the middle? Because they no longer are close to the blood supply. Okay? Without blood, you're not getting oxygen, you're not getting nutrients, so therefore you will cut it. Okay? All right. Stratum basale. Deepest layer of the epidermis is attached to the underlying dermis. In the stratum basale, your cells are actively dividing. They are dividing like crazy, okay? That stratum basale contains those tactile epithelial cells, or Merkel cells. And they have some melanocytes that help to produce pigment. Melanocytes. That pigment specifically is melanin. Okay. So if we have our dermis, this stratum basale has some keratinocytes. It also has some, they're going to be red for our purposes, melanocytes hanging out in there. Okay? And they're dividing like crazy. A human being has anywhere from 10 to 25% of their cells in the stratum basale being melanocytes. It's important to note that these melanocytes make the pigment, but they are not the ones who express that pigment. Okay? So this image that we're looking at here is our skin, all right? This layer here is the basal layer, the stratum basale. Okay. And then stratum spinosum, stratum granulosum. It's pretty small right in here. Oops, sorry. Right in here. Stratum lucidium. You can't really see it, but it is kind of right there. That clear layer. And then stratum corneum is all of that. All right. What's the next layer? What's it called? Stratum spinosum. It is named stratum spinosum because the cells look spiny. What did I say? Biologists, not creative. It looks spiny. It said spine name. That's your name now. Okay? The cells themselves aren't actually spiny. It's just kind of, as we're preparing these slides for us to view, they get cut kind of weird and they look spiny, but they're not. The cells that we're talking about are usually keratinocytes. Keratinocytes. They contain some thick bundles of intermediate filaments, and they resist tension quite a bit. Okay? They contain pre-keratin, so not quite keratin, but some pre-keratin. You also have your dendritic cells hanging out in this layer. And these are your immune system cells. What is the next layer? Yeah, next layer is stratum granulosum. Also to note, layer stratum spinosum is several layers thick. Okay. Stratum granulosum is about 1 to 5 layers. It has a few layers of some keratinocytes, but those keratinocytes are starting to kind of weaken out, right? They're farther and farther away from the blood supply, so they're losing nutrients. They're not exactly at their tip-top shape. All right? Those keratinocytes, remember in the layer prior we had pre-keratin. Stratum granulosum has these fun granules, the keratohyalin granules that make keratin. Before we had pre-keratin, now we have keratin. Okay. Why do you think this layer is called stratum granulosum? It has granules in it. It looks grainy and granular. Granular, is that a word? I think it is, right? Yeah, I'll take that. I'll take that as yes. Granular, okay? It looks granular. They named it stratum granulosum. Biologists aren't creative, okay? So those keratohyalin granules help to form keratin, and then the lamellar granules help to waterproof. They contain a waterproofing glycolipid. Okay? So anything above the stratum granulosum, the cells are way too far from the dermal capillaries to get any nourishment, meaning they will die, right? We have our dermis, and we have some capillaries kind of running through there. We have basale. Imagine I did Basale better. We have spinosum. We have granulosum. Anything above here is probably going to be dead. Below here, alive. Okay? Next layer that we talk about, this is our special layer. You don't always see this layer. This is stratum lucidum. Lucidum meaning clear. It is translucent. Heard that word? Translucent. Translucent means you can see through it. That loose is quote unquote clear. Don't quote me on that, okay? You only see this layer in thick skin. And it is just a few layers of dead, flat cells. I'm abbreviating keratinocytes as K cells because I don't want to write keratinocytes anymore. Okay? K cells are keratinocytes. Again, you only see this layer in the palms of your hands and the soles of your feet. Okay. Last layer of the epidermis is the stratum corneum. Okay. Are the cells in this layer dead or alive? Dead. They're hella dead. All right. They've been dead for like a couple of layers now. It is the top layer of your skin, and it helps to protect your skin against abrasions, and penetration. Right. So if you, I don't know, accidentally stab yourself with a pencil or something, you're not going to get through all the way to stratum basale. You're probably going to hit quite a few layers of that stratum corneum, right? It's pretty thick. It can handle a little bit of wear and tear. Not much, but a little bit. Cool? Cool. So, alrighty, let's chat. Starting from the bottom. By the bottom, I mean the layer that is closest to dermis. To dermis. Yeah, that is the basal, basale, whatever. Stratum. And are those keratinocytes dead or alive? Why? Yeah, they're hella close to that blood supply. All right. Okay. Next layer. Let's do a raised hand on this one. Layer 2. Volunteer, you'll be voluntold. So, yeah, stratum spinosum. Stratum spinosum. And are those cells dead or are they alive? They're mostly alive for the most part. They're chilling. They're okay. They're getting a little bit of oxygen, a little bit of nutrients. At stratum basale, we are actively dividing. Actively divide. So we're making more and more and more and more and more. Stratum spinosum, we're not doing as much division, but we are still alive. All right, we're still alive. We're still hanging out. Okay. Third layer. Stratum granulosum. Yeah. Stratum granulosum. Are these cells dead or are they alive?
Alive but slow.
They're alive, but they're dying, right? Alive, but dying. Right? Why? Yeah, they're getting too far from our blood supply for us to take the oxygen and nutrients that we need, okay? The fourth layer, again, this is our special layer. What's it called? Stratum lucidum. Where do we find stratum lucidum?
Palms or soles of feet?
Yeah, thick skin, the palms of your hands, the soles of your feet, okay? Are keratinocytes dead or alive?
Dead, gone.
They're dead. At this point, they are too far, they're dead. They're gone. They're not having a good time anymore. Okay? And then our last layer, stratum corneum. And our cells are super, super dead. Hella dead. They have been dead for a minute. They are no longer hanging out with you. They're just part of the party, but not even really, okay? They're like the part of the party that went home already because it's past their bedtime, okay? Yeah, me too, dude. Me too, for real. Bedtime is like 9:30, 9:45 on a good day. Okay, cool. So those are the layers of the epidermis. You will need to know what other cells might be in these layers at different times, okay? Basale has some melanocytes, spinosum has some dendritic cells, etc. Okay? Cool? Cool. All right, so we talked about the epidermis. Now let's talk about the dermis, okay? The dermis is the second major region of the skin. It's super strong, pretty flexible, and has lots of blood vessels and nerves, okay? There are two main layers to the dermis, the papillary dermis and the reticular dermis. The papillary dermis is more superficial, and the deeper reticular dermis is below. The reticular layer makes up about 80% of the dermis. Okay? The papillary dermis has what we call dermal papillae. Right? Look at the names, dermal papillae and the papillary dermis. It's right there. And those papillary dermis, the dermal papillae are little kind of finger-like projections, kind of like our microvilli, right? That help to increase surface area for exchange of gases, nutrients, waste. Because we remember our stratum basale is hanging out right in there, right? And this has actively dividing cells. So they need all that nourishment, they need all the energy and all that jazz, okay? Those dermal papillae lie on dermal ridges. And those dermal ridges will form epidermal ridges, okay? Since they're underneath all of the other layers of your epidermis, right? Those dermal ridges will eventually form epidermal ridges, that kind of bumpiness. And that bumpiness is what makes fingerprints, okay? If you look at your finger right now, you'll see all kinds of like lines and bumps and moves and grooves. That is because of the dermal papillae. Okay? Everybody's fingerprints are different, except if you have an identical twin. Your fingerprints, I believe, are exactly the same. Okay? These epidermal ridges also help to grip things. You ever been in a pool or a bath for way too long and your fingers get all wrinkly? Yeah, that's also to help kind of grip things in water. That's an evolutionary holdout from way back when. Okay? The reticular dermis, the remaining 80% of the dermis, is made up of dense, irregular connective tissue and forms cleavage lines kind of between the collagen fibers, right? We have what we call flexure lines in kind of your palms, your wrists, your fingers, your toes, and those are just those kind of big old lines that you see in your hands. If you look at your hands, you'll see some lines where your hands kind of just naturally fold. Those are flexure lines. Okay? You have them on your toes too, your wrists. Anywhere that bends kind of naturally, you'll see those flexure lines. Okay? The reticular dermis is super vascularized, has a very rich nerve supply, very vascular. Very vascular meaning that it gets a lot of blood. Okay? We have two vascular plexuses. That a plexus is just a place where a nerve meets a target. And those two vascular plexuses are the dermal plexus and the subpapillary plexus. And that subpapillary plexus is just below the dermal papillary, and it feeds both the dermal papillary, derm pap, that's what that is, and the epidermis. The dermal plexus feeds the hypodermis or subcutaneous layer and the deep dermis. That's talking blood supply. Okay. So the subpapillary plexus provides blood to the epidermis and the dermal papillae. And then the dermal plexus provides blood to the deeper layers of the dermis and the subcutaneous or hypodermal layers.
Sorry, after it says subpapillary plexus, what does it say? Like
just below. That's just an arrow pointing down. The dermal papillae. I didn't have space to write the whole word, so I just wrote derm pap. You see derm pap anywhere? That's the dermal papillae. Okay. Derm pap in the epidermis. Cool? Cool. Your body naturally creates these kind of dermal lines. We call them cleavage lines for the most part. And if and when you're doing surgery for all of my future surgeons out there, you generally want to make cuts along those dermal lines because they tend to heal a little bit better, right? If you're cutting through a bunch of dermal lines, it's going to take a little bit more for them to stitch back up, right? Okay. The hypodermis, also the subcutaneous layer. I will usually abbreviate that as sub-Q because I'm not writing subcutaneous every gosh darn day, right? Is also called the superficial fascia. This hypodermal layer is made up of areolar and adipose connective tissue. Its function is to anchor the skin to the underlying structures. And because it has adipose tissue within it, it helps to insulate the body. Remember that adipose tissue, fat, helps to insulate and retain heat. Okay? That hypodermis or subcutaneous layer has different distributions in males and females. So your twin brother might have some different distribution of hypodermal skin than you do. My female presenting twin. Make sense? You with me there? Males have a lot more hypodermal skin in the anterior abdomen. And females tend to get it a lot more, males, in the thighs and the breasts. Okay. All right. So earlier in the epidermis, we talked about melanocytes, right? Melanocytes produce melanin that helps create some pigment in our skin. It is not the only pigment that our skin makes. Okay? The most important of those pigments is melanin. Melanin can be yellowish, it can be reddish, it can be black, it can be brown. It just depends. Okay? Melanin helps to protect your skin against UV damage. That might be why an old stereotype we've heard is that black people don't need to use sunscreen. You do, is protecting your skin, but we have a lot more melanocytes that also do quite a bit of protection on their own. But let's not make them work any harder than they have to. So please use sunscreen, everybody. Yes, the sun will burn you. All right, next cell. These create a yellow-orange pigment. You see these a lot in carrots, tomatoes. It is called carotene. Okay? And then the last one that we talk about is hemoglobin. And that's what lets the kind of reddish color of your blood show through. So if someone gives you a cute little flirt, you might blush a little bit, and you might see a little bit of that redness coming through in your cheeks, okay? Remember, we get those melanocytes in what layer? In the stratum basale. They make all that melanin, and then they put it into the keratinocytes. So our keratinocytes are actually the cells that show the melanin. Does that make sense? So the melanocytes make it, and then the keratinocytes show it. Okay? Cool? Cool. All right. Let's talk nails. So nails are a modification of the epidermis. Your nails are made of hard keratin. Okay. Don't judge the finger that I'm about to draw. Oh, Lord. You got a long ass nail. All right. Sorry. Sorry to the recording. My bad. So every time you have the free edge. Okay. The free edge is the part that grows away from the body. That's that free edge. That's the part that you put your little French tips on. They're cute, right? Great. The nail plate itself is the part that is attached to your skin, right? You can't just rip your nails off. You shouldn't be able to just rip your nails off. If you can, please go to a doctor, okay? But the part of your nail that you can see that is very clearly attached to your skin is the nail plate, okay? The nail root is the part of the skin that is actually the part of the nail that is actually embedded into your hypodermis. Not hypodermis, I'm sorry, epidermis. Okay? So the root is but it's deep in there, right? Okay? That root is embedded directly in. These nail folds are the parts of your nails that kind of fold over, right, on these sides. For those of you that have gone to get a pedicure and your nails are super overgrown, that part that they push down the sides of your nails? Those are the nail folds, right? They're pushing those nail folds down and out of the way. All right? And then the last part, the epontium, whatever the guys. It's a cuticle, okay? It's a cuticle. It's this part. It's the cuticle. Your cuticles get dry and they crack, and they're the part that, in the winter especially, if you peel it, you can straight up just peel your whole body off. You know what I'm talking about? You know what I'm talking about? Great. Glad I'm not crazy and alone in that one. But your cuticle is that kind of back part of the nail, that thick back part. Okay? The rips your whole skin off part. You know what I'm talking about? Great. Cool. I do this every time. I draw a bunch of pictures, but there's pictures right here. Beautiful, right? So you got the free nail edge, you got that little bit, the nail plate stuck to the skin, lateral nail fold, another lateral nail fold, and then the cuticle. I'm not going to try to say that word again. I don't know how. It's a cuticle. Okay? Cool? Cool. Next little bit of skin, appendages of the skin, hair. Your hair is flexible strands of, guess what? Keratin. Are they dead or are they alive? They are dead. Your hair is just a bunch of dead keratinized cell. Keratin. keratinized cells. Okay? It is hard keratin. It is tough. It is durable. But it is in fact dead. Okay? There are two main parts of the hair that we talk about, and they are the root and the shaft. The root, your roots grow out. That sucks, man. Bummer. Happens. The shaft is what you can actually see. Your hair has 3 layers to it. You have the medulla, the central core, the cortex surrounding that medulla, and then you have the cuticle. Okay? These 3 layers all have keratinized cells in them. Okay? All keratinized. Okay? So, we're talking hair. This is the medulla. This is the cortex. And this is the cuticle. I know you can't really see it. It's okay. Okay? Another image. This is the hair shaft, or the hair itself of the hair, and then the hair follicle, right? Hair and hair follicle are not exactly the same thing. But the hair will have the medulla, the cortex, and then the cuticle. Okay. So the hair follicle extends from the epidermis into the dermis, and the wall of that hair follicle comprises of the peripheral connective tissue sheath, the glassy membrane, and then the epithelial root sheath. I'm going to show you guys a picture on the next slide that shows these out a little bit better. Okay. The hair bulb is deep, so it's in kind of the dermal layer, and it is expanded end of the hair follicle. And then the root plexus is just a knot of sensory nerves and other things that kind of wrap around the hair bulb. So it'll kind of look like that. And mind you, my hair is in there, right? And you have layers of nerves. That's that root plexus, okay? It's the epidermis. Okay, so that bulb kind of hangs out in the dermis, and then the hair shaft itself pops out in the epidermis. Okay. So this is our hair root. That's our hair. Okay. This is the medulla. We got cortex. We've got cuticle. This cuticle is just this teeny tiny little white sliver in between there. Okay. And then that hair strand itself is wrapped in a hair follicle. Okay. And that follicle is made up of the internal and external root sheath. This is the internal, this is the external. There is a teeny tiny little glass membrane here, glassy membrane, and then the peripheral connective tissue. You with me? Kinda. I know. It's a lot. I'm sorry. Okay? But that's kind of how that hair will grow up and out. That's kind of why you get split ends too, right? It's the follicle wall kind of splitting off into different sides. Again, another image of the same thing. You've got that external root sheath, the peripheral connective tissue, medulla, medulla, cortex, cuticle, all that jazz. Okay? All right. Another appendage of your skin are the erector pili muscles. The erector pili muscles are useful in trying to keep you warm. Okay? They are smooth muscle. Because they're smooth muscle, are they voluntary or involuntary? Involuntary. Involuntary. You don't have any control over when your erector pili muscles react. Okay? That erector pili muscle pulls hairs and makes them stand on end, giving you goosebumps. That's where goosebumps come from. Your erector pili muscle was activated. It said, I'm going to pull it. And now you have a little goosebump, and all of your hairs are standing on end. Almost like when a cat gets scared. You know how their backs get all like fluffy? It's like that, but with your skin, and the hair on your arms is probably not as thick as a cat's fur, but you get the gist of it, right? If I were to drop the temperature in this room super, super quick, you would start to form some goosebumps. Why? Your body is trying to use muscles to keep you warm. Okay? There are different types of hairs on your body. Vellus hairs are the body hairs of women and children. They're usually pretty thin. They're not super coarse. They're just kind of hanging out, right? They're very light, gentle hairs. Terminal hairs are the hairs at your scalp, the hairs at your armpits, and your pubic area. Those hairs are a lot thicker. They're a lot coarser. They're there. They hang out. They're the thick boys. Okay? And then as we get older, we can get hair thinning and baldness. Usually you see baldness a lot more in males. We call that male pattern baldness. It's usually genetic. Usually if your father goes bald at like 30, you're probably going to go bald right around 30, right? So that genetic male pattern baldness. But women also do lose hair. Your hair thins and it becomes a little bit more brittle as we get older. That's just a facet of it. Okay? I got 5 more minutes. Great. Sebaceous glands. Sebaceous glands are oil glands. They're the annoying boys that give us pimples and stuff like that. You'll see them all over your body except for the palms of your hands and the soles of your feet. They secrete an oily substance called sebum. And that sebum is secreted from simple alveolar glands. What does a simple alveolar gland look like? It is one duct and one unbranched duct, and a circular kind of sac, right? Our sebum glands do what we call holocrine secretion. And with holocrine secretion, the whole gland kind of bubbles up and breaks off. Holocrine whole. The entire cell breaks up to form that secretion. Okay? You'll mostly find these next to or near a hair follicle. You'll find that sebum is useful in collecting dirt and softening and lubricating the hair and skin. Okay? This little guy right here is a sebaceous gland. That's a hair and a follicle. These are the secreting cells. What kind of cells are glands? What kind of tissue is glandular tissue? Epithelial. And these are probably some cuboidal cells, because cuboidal cells do quite a bit of secretion. Okay? Another type of gland that we have these sweat glands or sudoriferous glands. And you'll see those things everywhere, okay? You'll find sweat glands pretty much everywhere in the body. I think the only place that you don't have a sweat gland is your actual legitimate eyeball, okay? Sweat, you'll find, is a blood filtrate, so it is a kind of a derivative of blood. It's mostly water and a little bit of salt. It contains a few metabolic wastes such as urea, ammonia, and uric acid. These are usually things that you would find in urine. But you'll also find them in sweat because sweat and urine are just filtered blood. Okay? Your sweat glands can be either eccrine or apocrine. And we'll talk about what those mean in just a sec. Okay? Sweat glands, sweat pores, all that jazz. Two types, eccrine, apocrine. You'll find eccrine glands all over the place. They're everywhere. And they produce true sweat. Apocrine glands, you'll only find those usually in the axillary region, the anal region, the genital region, and they produce a special musky sweat that helps you find a mate. If you ever, I don't know, people don't do that, but like if you've ever seen, I think there was like a BuzzFeed video or a bunch of dudes wore some shirts to sleep, and then they had people come in and smell the shirts, right? Yeah, it's that sweat that they're smelling that helps your brain say, hey, this person has an immune system that's very different from mine. We should make a baby so that that baby has the best chance of surviving. That's basically why it's stinky. Stinky. You know, middle schoolers, right? You with me? Cool. And then you have some other glands, these ceruminous glands and the mammary glands, and those are just modified apocrine glands. Mammary glands produce milk. Ceruminous glands produce, catch me on that one, okay? Another thing skin does, I'm sorry guys, I'm running a little late today. First degree burns. You can burn your skin, try not to. You can have second degree burns. They suck. Third degree burns are the worst. They consume a lot of the thickness of the skin. The skin itself looks burned, blackened, etc. First degree, not too bad. Second degree, you might get a little blister, all that jazz. Okay? First degree is itty bitty. Second degree, you'll get some blistering. Third degree, you've burned the skin off. It needs time to heal and repair. There are different numbers that we talk about in regards to like how much of your body is burned if you burn a lot of your body, right? So if you burned the entire front of your chest, you'd burn about 18% of your body, right? That's a pretty significant amount. Some other bad things that can happen with skin: you can get skin cancer, basal cell carcinoma, squamous cell carcinoma, and melanoma. Those are all just different types of skin cancers that have to do with the cells in a specific region. Okay? That's what it looks like. Throughout your life, your skin develops. It starts, the epidermis forms from your ectoderm. Your dermis and hypodermis form from the mesoderm. And the melanocytes form from your neural crest cells. We talked about those in chapter 3. As a fetus, your skin is formed pretty well after the 4th month. In month 5 and 6, you start to get what we call lanugo, that's what it is, lanugo, which is just those like really fine baby hairs. And then when you are born, you're covered in what we call vernix, which is just kind of a waxy substance that helps protect you. When you get old, your skin thins and becomes less elastic. It shows the effects of environmental damage, so use your sunscreen if you don't want to be wrinkly when you're old. And skin inflammation and bruising shows up a lot more often. Okay? All right, that's it. So, chapter 5 done.